This is part 2 of my series on third-person character footstep sounds. In part 1, we looked at how to actually implement them in Unity using animation curves. In this part, we'll look at building an editor tool to generate these custom curves and add them to the FBX's AnimationClip's curves for us. To avoid carpal tunnel, let's take a look at creating an editor script that will automate the creation of these curves for us. Let's create a folder called Editor. Unity will automatically strip out any scripts in this folder during a build, so we won't have to worry about wrapping any Unity editor namespace classes we use with ifdefs to avoid errors when building. I'm going to create a script called AnimationClip Footstep Curve Creator. If you've never created an editor window before, it's actually super simple. Just change the class to extend from editor window instead. Create a public static show window method. Create a window variable that's set to a call to getWindow, passing in our new class as the generic type, and I'll name this window Footstep Curve Generator. Let's call window.show and then add a menu item attribute to this method. Menu item takes in where in the toolbar we'll be able to find this window. Just to see something when we open this window, let's add a public void onGUI method and just throw in a quick GUI layout.label call. Hopping back to Unity, we can now find our editor window in the toolbar and see the message from our onGUI method. Now let's start coding this tool. The main idea for how this tool works is we'll simulate an animation clip playback on a character in the scene and record the height of the left and right foot at specific intervals during the clip. Then we'll basically just subtract the left foot height from the right foot height, and that result is our footstep curve. To do this, we're going to need a reference to a character in the scene, then a reference to an animation clip just for testing while we write this tool. Eventually, we'll want to run it on animations in bulk. Finally, let's add a float called Preview Slider that we can use to preview the animation in the tool and make sure everything is working well. Inside our onGUI method, I'm going to change the label to something a little more helpful and then add a space below it. Now, let's set our scene reference model to editor GUI layout.object field. The first parameter is the label for the field, the current value of the field, the type this field takes, which in our case is a GameObject. And then we want to pass in true for allow scene objects because otherwise it only allows you to select GameObjects from your project, not GameObjects that are active in your scene hierarchy. Lastly, make sure this object field is casted as a GameObject. If we hop back to Unity, we can see our editor window now has a space to drop our policewoman. Now, let's get an animation clip playing back on her. Let's add another object field for the animation clip, this time passing false for allow scene objects because animation clips don't live in the scene. Let's add some space again, and then call GUI layout.begin horizontal and end horizontal. This will put our next GUI calls side by side instead of putting each on another line. In here, we can add a label for playback preview and then set our preview slider to editor GUI layout.slider and clamp that between 0 and 1. If we hop back to the editor, we can see our window looking a little better. Let's assign the walk forward animation clip for now. To get the slider working, let's create a private float called last slider, then at the bottom of onGUI, set last slider to the current preview slider value. Now, we can just check if preview slider doesn't equal last slider, then call clip.sampleAnimation, passing in the model we want to preview the animation on, and the clip length multiplied by the preview slider to get the time during the animation we want to preview. Back in Unity, now we can see that as we drag the playback preview slider around, we can preview the animation on our policewoman. Now let's work on generating that footstep curve. I'm going to check if scene reference model and clip are both populated, and if so, add a GUI layout.button here with the text generate footstep curve. When this button is pressed, we'll call a new method called sample clip, passing in the animation clip assigned in the editor. We're passing in the animation clip for now because eventually we'll be calling this method inside a loop to process many animation clips in bulk. Let's add some animation curves for left foot and right foot. I'm also going to introduce an int variable called sample precision, which we'll use to determine how many intervals we sample the footstep heights at. Now we can just add another begin and end horizontal section for the label and an int field for precision. At this point, I notice that I set sample precision as a float when it should be an int. I'd like to mention that there's constructor overloads for the int field and slider that lets you set a label without having to use the begin and end horizontal sections, but it's fun to see the different tools available to us when building editors, so I decided to do it this way. Now that our editor is looking good, let's start working on that sample clip method. Let's grab a reference to the scene reference models animator and make a for loop that goes from 0 to clip.length multiplied by sample precision. Inside that for loop, we'll use the sample animation method like before, passing in the scene reference model. I accidentally passed in clip length times preview slider here at first, which will obviously not work because this will keep sampling the same point. I'll circle around and fix this bug in a minute once I realize my mistake. Now, let's create a variable for left foot height by calling a new method called getLowestHeightOnFoot. This method takes in the animator and a bool for if we're checking the left or right foot. Let's also create a variable for right foot height while we're at it. In getLowestHeightOnFoot, let's create a variable for the toe bone, which is equal to either the human body bone's left toes or right toes, depending on that isLeft bool. And now let's create another variable for the foot bone. And finally, let's create a variable for foot bottom height. This is equal to either the animator's left or right feet bottom height. The feet bottom height variable is the distance between where the foot bone actually is and the actual bone in the mesh's foot. This is because typically in games, a foot bone will be located in the ankle, so you rotate the foot around that bone and it would not be located at the bottom of the foot. We want to check both the toes and foot positions because when walking, the animations can be anything from walking heel to toe to walking on tippy toes, so it's best to check both places. To calculate our toe height, we call animator.getBonePosition, passing in our toe bone, and then grabbing that bone's transform position y. This bone is actually optional on humanoid avatars, so that's why we need to add a null check before it and default it to some really high value in case that bone doesn't exist on our specific model. Next, we do a similar process to grab the foot height. This bone is required on humanoid avatars, so we don't need to do the null check. We also need to subtract the foot bottom height here, so we get the distance from the ground to just the bottom of the foot model, not the model's foot bone, which again is located in the ankle. Now just return mathf.minimum of either the toe height or the foot height. Back in our sample clip method, we can just add the left and right foot heights to our left and right foot curve as keyframes, where the time is I divided by clip.length multiplied by sample precision. We're getting really close to being able to test if our algorithm works. Let's just add some curve fields to our GUI for the left and right foot curves. Let's also add a label for the value of the curve evaluated at the preview slider position, just so we can get a better visual when scrubbing through the animation. Now it's finally time for me to fix my bug from earlier. In the sample clip method, let's change the sample animation call to sample at I divided by sample precision, casted as a float. Let's also set our left and right foot curves to new animation curves here to clear out any old keyframes from before. Moment of truth. Clicking the Generate Footstep Curve button indeed generates two curves for the foot height along the selected animation. We can see that scrubbing through the animation, these curves match up with the foot heights for the left and right foot. Let's improve our editor visuals just a little bit before continuing. I'm going to add a visual overlay on the curves so we can see the playback position on top of the curve. To do this, let's make a variable called rect equal to the GUI layout utility.getLastRect function. This returns the rectangle where the previous GUI layout control was drawn. Now let's multiply the rect's width by the preview slider and then render a GUI.box passing in the rect. I'm also going to do the same thing with the right foot curve really quick. Back in Unity, we can see that dragging the playback preview slider, it superimposes a box over the part that's already played back. This, combined with the result value label, will really help us as we start processing these curves in the next step before generating the final combined curve. First thing I want to do is normalize a curve so it has a height of 1. Back in the code, let's create a new Normalize Curve function and call it for both our left and right foot curves. Inside this function, create a new return curve and return it. Now, let's make some variables for min and max value of our curve keyframes. make a variable called height, which is just the max minus the min. Now we can just loop through all of the curve values, divide the current value by the curve's height, and then add that keyframe to our new return curve variable. Back in the editor, you can see that generating the curve doesn't look like it changes them visually, but if you open them up, the curve is just taller. Now, let's introduce a threshold variable defaulted to 0.1 and then set any keyframe that isn't the first or last keyframe and has a value lower than the threshold to 0. Generating the curve again looks a bit more tidy, but you can really start to notice the tangent issue now. The line looks a little wiggly even when the value of the keyframe is 0. Fixing the tangents takes a bunch of math, so it's easier if we just set them all to linear instead. To do this, let's call a new method called convertCurve to linear and pass in the return curve. This new method will just loop over the keyframes in the animation curve and call the AnimationUtility.setKeyLeft and right tangent mode methods, passing in the curve, the index, and tangent mode of linear. Back in Unity, we can generate the curves again and see that the curve has gotten all of its wiggles out. Real quick, let's also call our Normalize Curve method for the right foot curve as well. Now, let's get to the process for combining these curves into our finalized result. First, we'll need to make a new animation curve to store the combined value. Let's also copy the curve GUI from one of the other feet, but change it to be for the combined curve variable. Let's also set combined curve to be a new animation curve in the sample clip method, just to clear out any old keyframes. Now we can set combined curve equal to a new combined curves method and pass in our left and right footstep curves. In this new method, let's create a new return curve like before and return it at the bottom of the method. Next, let's make a for loop that goes from I to sample precision. Let's make a variable called time, which is set to I divided by sample precision. Then we add a key to the return curve where the time is our time variable and the value is the right foot curve evaluated at time minus left foot curve evaluated at time. Finally, let's convert the curve to linear before returning. I'm also going to make an onValidate method that sets the 3 curves to be new animation curves if null, just to fix any potential console errors we might have when we're calling editor GUI layout.curve field and passing in a null curve variable. Back in Unity, we can see that we can generate this curve successfully, and it looks very similar to how we would have handmade the footstep curve in the first part of this video, just with a little more detail. We're just about done. Now we just need to write this combined curve to the AnimationClip's curves. My first attempt at this actually didn't pan out, but it was to write the curve to the AnimationClip. I have a suspicion of why though. When viewing the AnimationClip from the Animation tab of the FBX it's from, we can see the original footstep curve I made in the first part of this video. However, when viewing the footstep curve on the AnimationClip itself, we can see that it's the newly generated one. If you've already seen my video on serialization, then you might have an idea of where I'm going with this. So let's do a quick restart of the Unity editor. Now, when we look at the walk forward animation clip again, sure enough, the curve for Animator.Footstep has reverted back to the handmade version that's from the FBX. Clicking Generate Footstep Curve again will update it, but this clearly isn't getting saved. Digging through the FBX's meta file in VS Code, we first find the curve for our idle animation with only the 2 start-end keyframes with a value of 0. And then next, we find the handmade one for our walk forward animation. Our generated curve isn't anywhere to be found in this meta file. Now, this method might have worked if we were dealing with animation clips we created in Unity, but when working with FBX files, we need to update their meta files where those custom curves are actually getting serialized. Fortunately, this isn't that hard to do. Your first step should be to remove those last 2 lines since they don't actually work. I forgot to do it at this point, but I'll get back to it later in this recording. Next, let's call AssetDatabase.getAssetPath, passing in the clip, and assign it to a variable called AssetPath. Then, let's call AssetImporter.getAtPath, passing in the asset path, casted as a model importer, and assign it to a variable called importer. Now, let's create a new serialized object passing in the importer, calling it SO. To break down what's happening here, getAssetPath will return the relative path to the animation clip we're passing in. In this case, because the animation clip is coming from the FBX itself, this method call will return the path to the FBX file. The next call to assetImporter.getAtPath will get us the model importer, which is a way to change any of those import settings you see on a model from code, including settings on the rig, animation, and material tabs as well. Finally, creating a new serialized object and passing in the importer will allow us to serialize the curves to the meta files like we want. If you've never used Serialized Object before, you see them all the time in custom editors, because making changes through there instead of directly using the target property will tie the changes into Unity's undo system and be detectable by Unity's scene save system. Now let's call so.findProperty passing in m_clip animations. I was able to find this variable Unity uses internally to store the animation clips on an FBX by calling serializedObject.getIterator and looping over all of the properties. Running this code and then looking in the console, you can find m_clip animations in the list of properties. This next part you don't actually need to do, but I'm creating a new array of model importer clip animations and copying them over from the importer.clipAnimations array. You don't need to do this since you can just use the importer.clipAnimations array for everything. I think I was just getting a little lost in the sauce, as the kids would say. This next part might get a little confusing, but basically we're just going to loop through the FBX's animation clips until we find the animation clip we've generated this combined footstep curve for. Then we're going to loop through the clips' curves to either update an existing curve named footstep or insert a new curve onto the animation clip. To start, let's loop through the importer.clipAnimations, create a variable called anim that's assigned to importer.clipAnimations indexed with I. Then if the clip.name is equal to the anim.name, we know we found the animation clip we want to update the curves for. The next step is to find the curve within this clips' curves array that we want to update. Let's start by creating a variable called index set to -1. This way, if we loop through and the value is still -1, we know that we need to insert a new curve into the array. Now, just another for loop and go through anim.curves and check each one if its name is footstep. If so, assign index to j and then break out of the loop. The reason we're doing this is because animation clips can have any number of curves on them. I use curves all the time in my video games, and some of the animation clips in my game Samurai Unicorn can have upwards of a dozen different curves to help steer gameplay logic, like defining sections of the animation where the player shouldn't be able to move or rotate, blending head or hand IK on and off, setting when attack animations can be parryable, setting when during an attack it's available to combo into another attack, etc. Now, let's grab a first or default from the curves array where the name is footstep. We're doing this because in the case where the curve doesn't yet exist, this call will return an empty clip animation info curve struct, which, as I talked about in my previous video on the Playables API, structs can never be null since they're value types, just like ints or floats, which are defaulted to 0 when not set, not null. So now that we have the curve, let's make sure the name is footstep in the case where the name has not yet been set the value to the combined curve we generated, and then make another variable called isInsert that's set to if the index is equal to -1. If this is an insert, this means we need to append our new footstep curve to the array. Otherwise, we just need to override the existing curve with our new footstep curve. Now we just need to loop over the actual serialized clip animations curves and update them with the values from our anim.curves array. To do this, let's call clipprop.getArrayElementAtIndex passing an I. This is referring to our specific animation clip in the FBX's m_clip animations array. Now let's call findPropertyRelative passing in curves. This returns a serialized property representing the array of curves on the animation clip. Now we can loop over the anim.curves array, and first let's check if the index j is greater than the serialized curves array size. If so, this means the clip doesn't currently have a footstep curve, so let's call serializedCurves.insertArrayElementAtIndex passing in j. This creates an empty curve with the default settings at that index. Now let's create a new variable called c assigned to serializedCurves.getArrayElementAtIndex passing in j. This is the specific curve we want to copy over the details for. Call c.findPropertyRelative passing in curve. FindPropertyRelative will find a child property of the current serialized property we're working with, which in this case is the specific curve from the curves array that lives on the animation clip that came from the FBX that has a bunch of our movement animation clips on it. Let's set the curve property AnimationCurve value to anim.curves indexed with j's curve property. Now let's do the same thing again, but for the name property, setting the string value to .name. After all of this, let's break out of the for loop, because remember that we're just here looping through all of the animations just to find the one specific animation with the name that matches our animation clip we generated the curve for, so once we find it and update the curve, we are finished. And last but not least, let's call the serialized object's apply modified properties method, which will actually write our changes to the animation clip's curves to disk. And so, let's test it out. I'm going to find our walk forward animation, change the existing footstep curve's name to something else, and then press the Generate Footstep Curve button. And now, when looking at the walk forward animation's curves, I can see that it added a new curve called footstep with the expected combined curve. If I go in and reset the footstep curve to be a flat line, then regenerate the curve, it updates the existing footstep curve with the combined curves variable. At this point, I'm going to finally clean up those two incorrect editor curve binding lines from earlier. Now that this process works for updating a single animation clip, let's get this to process all of our locomotion clips at once. There's any number of ways to accomplish this, from changing the clip field to be an array and dropping a bunch of animation clips on it, or grabbing all the animation clips for a specific FBX file and processing them at once. For this project though, I'm going to grab the Animator controller from the scene reference model, and then process all of the animation clips currently on it that don't match some kind of ignore list. To do this, let's grab the scene reference model.get component of type Animator, and then grab the Animator's runtime Animator controller. Now, let's just do a for each over the runtime Animator controller's animation clips, calling sample clip for each. Let's introduce a string called ignore list, which I'll default to idle. Outside of our clip loop, let's split the ignore list on commas, and then select the trimmed string, just to clean up any white space. Next, just check if the toIgnore variable contains the animation clip's name, and if so, we continue through the array and don't process that specific clip. Last but not least, let's add an editor GUI layout.text field so we get a text field in the editor window. I'm also going to add jaw close to my ignore list because this specific character model has a jawbone to open her mouth. But when a humanoid animation clip doesn't have an animation for that bone, Mechanim is nice enough to leave her mouth open instead of shut, which you probably noticed earlier in the video while I scrubbed through the different locomotion animations with the playback preview slider. Just to make sure this ignore list works, I'm going to log out the animation clips that get skipped or processed. Moment of truth. Generating the curves for all of our locomotion animations took about 2 seconds, and the console log shows that idle and jaw close were both skipped. Now we can take a look at the different locomotion animations. We can see that unique footstep curves were generated for every one of them. Instead of spending 2 minutes manually creating 16 animation curves, we just spent half an hour writing our own editor window to do this for us. If that's not one of the most programmer things you've ever heard, I don't know what is. But jokes aside, this tool is great because in a full production game, our character can have both an 8-way walk and 8-way run cycles per permutation of weapon type, plus aiming and not aiming variants. This is the case for Samurai Unicorn, where each weapon has 32 different locomotion animations between lowered weapon 8-way walk, lowered weapon 8-way run, aiming weapon 8-way walk, and aiming weapon 8-way run. So 32 animations multiplied by the weapon count, plus 16 for unarmed. A tool like this can save me lots of time plus a lot of wrist pain. At this point, I realize that even though I have 16 locomotion animations in the blend tree, I'm really only showing off a few because a character always faces towards the movement direction. I'm going to add in aiming really quick just to help show off those moving backward and strafing animations. There's so many different fun places you can take a system like this. I recommend looking into having different samples for walking versus running like we have in Samurai Unicorn because I think that's a great little bit of polish. Plus, most footstep sound packs available for purchase will have both, so it's not hard to find good samples if you don't mind spending a little money. I also recommend adding some random clothing rustling sounds now and then during movement, since that also helps the character feel a little more dynamic. I hope this tutorial has been helpful. I can't believe my little channel has already hit 500 subscribers. It was just my last video that I thanked everyone for 300. I really appreciate everyone coming along with me. If you want to help support me, besides the usual liking and subscribing, My fiance and I made a puzzle game a few years ago that's available on Xbox and Steam. It's called Deja Vu, and it's a puzzle game about life, death, and clones. A link is in the description below. And before you give me any money, if you actually bought the Ukraine itch.io bundle from 2 years ago, then you already own it, so play it, have fun. That'll be all from me. Thanks for watching. I'm Eric Freeman, and this has been Game Development Beyond the Basics.